let me introduce the first speaker, Nigel Foley, who's the Analog CAD Director at CSR, Cambridge Silicon Radio. He leads the analog design methodology environment for a lot of teams, and he held similar roles at Surf. He's a rock star. Please join me in welcoming Nigel to tell us a little bit about how he does it.
First question we were asked to discuss was critical dependency management technologies you deploy for design. Well, first thing that comes to mind is we design IP no longer by chips, but by block function, by high-level block functions. So we design Bluetooth and Wi-Fi and different radios, different analog components, and they're self-contained, granular, and perfectly set up for reuse. How do we use those then? Well, we minimize modification. We want to keep our IC tree as small as possible. So in IC managed terms, think reference, right? We want to point to existing IP. It doesn't make a copy, it doesn't make a branch. If a reference won't do, then let's integrate it. Remember, you lose nothing by starting with a reference or a pointer, and you can then, at any point, change and branch it. Now, you can't do the same at local. Local is always new IP. So keeping our IP data small while avoiding starting with a blank sheet is critical. The last point is stabilize and provide initial IP for downstream teams, namely like chip integration, digital teams. Use early releases to combat shifting sands. There's nothing more frustrating than it worked yesterday and it doesn't work today. So release early, release often, get your chip integration, your digital teams working alongside. Incremental data deliveries will help avoid surprises and pipe clean the flow. So what about verification and bug tracking? It's critical to link your design management and your bug tracking system together. One of the biggest advantages of doing this is you can always put something you are going to do in a bug tracking system. You can plan for the future. Oh, we need to write a test for that. We need to fix this. And it's a much bigger relational database than just what you can attach to the actual IP itself. So you can capture why it's changed. You can capture relations between the data. Make verification and specification part of the IP as well. Try and have everything self-contained, encapsulated. Try have self-checking test benches, models, Verilog A, Verilog AMS, all of your assertions based. Have it all wrapped up in one piece of IP so it's there when it needs to be reused. Verification and any waivers as well on the IP needs to travel. You won't always be able to get back to the designer and ask him, why did you do this? Regression test as well, if possible. So when you're using that IP, integrate it early on into your design and regression test it if you can. Regression test it on release branches, on active development branches, and do it early and every night if possible. So what methods or incentives do you find most effective in improving efficiencies and gaining conformance to these dependency management processes? Well, have a group of people that designers can go to ask about IP. Have experts available to work when projects are starting to advise people on the best IP to use. Does it need to be referenced? Can we get away with a reference, or does it need to be integrated? Is this brand new IP? Let's set it up properly. Start design from the best possible place. And at the same time, drive home that IP reuse is part of the design. It's not just putting down transistors anymore. You've got to think about these things. And then enforcing that. Make IP a part of the design process and the documentation. So have compulsory alpha and beta deliveries to your chip integration team, all your downstream teams. Have standardized data handoff. It's really important going from an analog world, which is a little bit ad hoc, going to a digital world where everything is very heavily scripted, that you have standardized IP in the same format suitable for use in a scriptable environment. And that's coming from the analog teams. Automate that. Checklists and documentation for design review. Capture all of your IP, what you're using, when you're using, what release, what branch, everything should be captured. So what gains have we seen from implementing these kind of approaches? So let's start at the end. Chip integration. Well, work can start sooner because you're now giving chip integration teams, the guys who put the ICs together, skeletal alpha beta deliveries very early on in the process. Because it's standardized IP, you've got an automated process for encapsulating all the files and putting them in all the right places. It's more uniform and consistent. And because the chip integration teams are brought into the design as early as possible, you end up with better design choices. The top level guys can talk with the design teams and make sure we have optimum pin placements and we get good designs out. The design teams themselves, well, reduce the project design and the verification time. So because our IPs are kind of bigger building blocks, you can divide and conquer. Different teams can work on different IP functions, and you can put them all together. One very important one is the reduced risk aspect. Silicon-proven IP is the best type of IP. If you use silicon-proven IP as a building block, you can drastically reduce the problems on your chip. And everybody knows that our mask prices are escalating, so this is a really important one. It allows you to reuse all the work that you've done before and take shortcuts on the validation side, on the verification side, I should say, because it's already validated. And design teams are transitioned from oh, I'm working on this cool chip, to I'm working on this cool IP that's going to go into 7 different chips. It's a big transition that design teams will go through. And that's some of the benefits that we've had from reusing the IP and keeping it consistent in our organization. Thanks. We're lucky in the fact that we do have just Perforce and IC Manage, but we have dabbled around with the foreign depot and brought in successfully IP from the Perforce side is what we've predominantly been using, but I don't see any major problem with using the same methodology as long as IC Manage can support it. That's basically it. We develop our entire CAD environment inside an IC Manage. We treat it like a project. And we have a system in place that allows us to just populate it once in one area per project. And we can independently control which version of the tools, which CAD flow on a per project basis then. So we definitely don't put a version of everything. And when I say per project, it is one CAD flow being populated in one workspace for as many project users. So they all point to the same thing. It's not one per workspace. We've got some automation checks in place. We do regressions. We do checks to see if anything is broke by the latest check-in, for example. We can do it on the release branches. We do it on the development branches. So yes, there's always room for more improvement, I guess. You can always do more regression. But it makes a huge difference being able to find things very early, very quickly. When they've just been checked in that night, something falls over and you can immediately trace it back to something that you've just done. So it's very powerful, yeah. So we don't do it for our CAD flows because obviously not every project, the project picks their CAD flows and when to upgrade because they could be 3 days from tape out or they could be 5 months from tape out. So we do that on a per project basis.